Hi everyone, my name is José Vieira and I work at the Center for Artificial Intelligence and Analytics in Fidelidade Group. The insurance sector is full of data science challenges such as classical supervised classification models for customer cross-sell and churn propensity, as well as deep learning and computer vision exercises such as intelligent document processing, car damage assessment in either pictures or video, or even topic and sentiment analysis in either text messages or phone calls. All of these projects are built by our internal teams at the center. If you'd like to know a little bit more about our projects, feel free and reach out. I wish all of you a wonderful World Data League. Best of luck.
Fidelidade, so that life doesn't stop.
And hello. Welcome back again to the last live session of World Data League, and I think the most exciting one, right, Tamara?
Yeah, definitely. And also the bittersweet one, because it's where all the work culminates and everyone's waiting for it. But it also means that this World Data League for this year is almost over, but very excited, definitely.
Yeah, and it's actually a very special live session because now we get to see live what the best 5 teams of the competition did for this challenge, and I'm actually really excited to see a bit about it. Maybe Tamara, now that we're also finishing this competition, maybe what's the thing that you'll miss the most out of all of it?
Well, that's a difficult one. I think seeing the excitement, because I get to see the data before everyone else. So I always have like some idea of what maybe could be an approach, but every time the teams completely surprise me. And that this starts with the questions that I'm getting, ideas for other data, other avenues to explore. And I'm always like, there's so many smart people here working on the same problem. And I just love that sort of energy. I think that's what I'm always missing in the second half of the year. But yeah.
And now you also know next year if you participate whom you need to bribe to win the competition. All right. So without further ado, let's kick off this live session then. But before we start, just for the ones who are joining, maybe you're supporting the team, maybe you're just joining and would like to know a bit more what were the final outcomes. And then we will quickly present what was World Data League and what is World Data League. And I think the first things first is just kind of put the definition there. We defined as a data competition that brings together the best minds in data science, machine learning, and AI to build long-lasting solutions for social impact challenges. Now, of course, these are all very fancy words, but we're actually try to transform these words into concrete actions on what we do. So, for instance, it is a data competition, and a lot of focus goes into rather coding the algorithms rather than coding what could be a product, because the product can later on come with more effort. Then we also try to get the best minds in data science by contacting different organizations, academia, and so on to participate in our competition. And then finally, long-lasting and social impact. This is something that's really seen in the deliverables, that the teams do not only focus on creating an algorithm, but also think about how the challenge, the organization that proposed the challenge will also use that algorithm and what impact will it have. So basically, our vision is to ensure that in the future there is fast and accessible data-driven social impact solutions that could be used by anyone, and therefore we have a mission to accelerate the creation of accessible data-driven solution for social impact. And this can also be seen something through the Social Impact Hub. So if you go to our website and just look for the Social Impact Hub, what you will see there, it's already quite, I wouldn't say huge, but quite big collection of all the challenges that have been already through the competition, and where you can already see some ideas on how it could be solved, which data is needed, and also what else could be done to solve it. And of course, all of these solutions are open sourced. And now I will let Tamara to talk a bit about more the topic of specifically 2023.
Yeah, it was really an amazing year. As Leon said, World Data League is all about sustainability, data-driven communities, and figuring out how to have real social impact with data solutions. I think especially nowadays, where there's so much data around and there's so many people who are using data or AI to try to get insights, thinking about how to actually have a social impact and thinking about the impact that your solution will have is getting more and more important. And this year, under the umbrella of data-driven communities, we really wanted to focus on social development goals. There's 17 of them. I highly recommend reading all of them if you haven't yet. They really line out a great utopia and a great vision for humanity. And this time we had 3 challenges that we selected during the challenge gathering phase for 3 different social development goals. So the first challenge takes us back to Lisbon. For the teams listening, I think they will think of a grid over Lisbon, not over about the city of Lisbon itself, because it was an amazing data set with cell phone data and almost like a puzzle, figuring out, well, how are these people moving through that city, with, of course, the goal of making movement in Lisbon more sustainable and furthering soft mobility over car usage, especially during rush hour. Then the second challenge, we stayed in Portugal. We moved over to Cascais, and this was a completely different challenge. This time also with a unique data set because it was hand collected, literally, and Anna of the city of Cascais explained exactly how they collected the samples in the ocean to figure out what is happening with biodiversity in the Ampa region off the coast of Cascais. So the second challenge was not about big data, but about how to get insight from handcrafted data in the biodiversity field. So it was really about how do we figure out approaching a data challenge, maybe without the domain knowledge behind it. And then, of course, the finals that we will talk about today. So I will not say too much about it, not to spoil what the participants are going to tell you. But the final challenge today was all about energy. The city of Ghent had, again, an amazing data set where when I first heard, when Joyka told me what kind of data they had collected, I think my reaction was, wow, I had no idea a data set like this existed. You just flew a plane over your city and made a complete 3D model. That's amazing. And I'm super curious to see what the participants did with this data, with, of course, the goal to figure out how to have more sustainable energy in the city of Ghent and maybe other cities beyond. Yeah, those were the challenges. Let's talk about a few numbers. because I think the numbers are really impressive. We have 17 countries represented, and we had 109 participants in this edition. So you will see the finalists today, but of course there were a lot of other great teams that did a lot of great work, and that just didn't end up making the cut, but are no less part of WDL and did amazing work. And of the 29 teams, 25 teams represent a country, which means 60% of the team is from one country. But often they have some members that are from another country, international, and 4 teams were completely international. You don't really see it that well on the map, but really our participants are from all over the world, and that's one of the other great things about World Data League, that it's really diverse, and we really get insights from people with a lot of different backgrounds. For the league itself, we also have a couple of numbers. I'm not going to read through all of them, but what I really want to focus on is the first number, 93 days. So the participants have done a ton of work. It's a long competition, and I know a lot of time, a lot of effort went into solving these solutions on every step. And also we have a lot of jury members, 28 different technical jury members, and 15 mentors. And that's another thing that we really try to focus on. Of course, it's a competition. People are here to win prizes. And one of the goals is social impact. But part of the social impact is also that we hope that everyone who comes to WDL, be it someone who has already years of data science experience, or maybe even is academically involved in data science, which quite a lot of people were in this edition, 22% had over 4 years of experience. But also the people, I know that at least a few teams came in from the same data science bootcamp that I went to. So people who are at the very start of their data science journey. And we hope that everyone can take something away from the journey, and that everyone learns how to approach data problems with social impact in mind. And that's also in itself part of the social impact, because you are all brilliant minds who will go out to do great things. And we hope that you take something away from this league that helps you in your daily work.
And of course, all those impressive numbers and all of the impressive things that the participant did would not be possible without all the organizations and companies that are supporting us. So first, of course, I would like to thank all the corporate partners that helped not only contributing financially to the competition and allowing us to pay great prizes, and also allowing for the competition to happen and have resources, but also they provided mentors and jury members who evaluated and who also helped the teams. And just you can see all 8 of them on the screen. So it's BPI, Their Data, Euroclear, Fidelidad, Galp, GTA, Siemens, and Lithia. And I would really encourage you to get to know them, because I think it's already a good sign that they show interest in helping us out to use data for social impact. But it's not only corporate partners that helped us. There's more partners as well. So we, of course, have the 3 cities who provided us the challenges and the data, and who spent several meetings and who looked throughout several documents, and who were bugged a lot by Tamara as well during the last 93 days, or actually more, because the preparation starts way before that. And it's Lisbon, Cascais, and Ghent, but also our partner Eurocities. They've been a huge help in getting us in touch with different cities, trying to find where there could be interesting challenges and where could it be applied, and also in general helping us with a lot of promotion. And if we talk about promotion, we also had really 2 great communities that help us communicate what we are doing, which is Data Science for Social Good, Portugal, and AA Agents. And then finally, we had also had some cool perks, which all of you might have already a chance to receive it or to win something. And these were because, of course, of the support of these companies. All right, now that I think we presented more or less what is World Data League, how we're supported, how it works, I think now it's time that we actually jump to the final stage of the finals. So just again, to give an overview how this will work. First, each team will have a 5-minute pitch to the grand jury. So actually all of these solutions have been already evaluated by the technical jury, and 50% of the, more or less 50% of the points have been already attributed, and the grand jury is going to be responsible for the other 50% of the points based on the pitch and the Q&A. So, and who is this grand jury? Where we have I think a really great selection of people who will be really great to evaluate the solutions. So first is Joyka Leple. I hope I'm pronouncing this correctly, Leple. Maybe you can say hi. I don't know if you're already there.
Hi.
Yeah, perfect. So she's the senior team coach mobility at the city of Ghent. But before that, she was actually working more on the energy and environment. And then this is where she also came up with this challenge. So she's well aware of what data there is. She's well aware what is the problem of Ghent. And I think she will ask some very tough questions. Then we have Lambert Hogenhout. Again, hope I'm pronouncing this correctly. He's the Chief Data Analytics and Emerging Technologies at the United Nations. So since we do want to have social impact and we do want to focus on the UN Sustainable Development Goal, I think it made, of course, a lot of sense to have someone from the United Nations to also help us evaluate these solutions. And finally, Stefan Verhoost. A lot of you might already know him from previous live sessions. If you participated previously at World Data League, for sure you know him. It's already his third live session with us and second time as jury. He's the co-founder of GovLab at the New York University, and he's been working with a lot of cities from around the world, looking to their problems and what could be done to help them, and specifically also with data. So, in a bit before, Tamara was already giving you a hint of what is going to be the challenge, but maybe let's remind also the viewers what they're going to listen about, Tamara.
Yes, of course. As I said, I don't want to take away too much from the presentations, but as a quick overview, the city of Ghent proposed a challenge that they want to create energy communities, especially being inclusive of residents vulnerable to energy poverty. So the idea was the city of Ghent is already doing a lot of things aimed at improving the sustainable development goals. And they were thinking they already have some solar power. They want to be able to help their city even more to adapt sustainable energy via using energy communities. And an energy community is a group of people, usually that are quite close locally, that use the same energy sources. So if you imagine you have a neighborhood and there is one roof that's perfect for solar cells, maybe the community can get together and this whole neighborhood can get part or all of their electricity from that roof. And the city wants to facilitate these sorts of communities, but the city of Ghent was also very open to how solutions can be proposed to this challenge. So should it be local? Who should be included? How do you decide? And how do you propose and present this challenge? So the challenge was very open with very interesting data. As I said, there was a 3D model of the whole city with every single roof where it was decided which roofs were suitable for solar panels. I think it even was taken into account if there was a tree in the way. So extremely elaborate data sets that the participants worked with. And yeah, I'm super curious what our teams did. And I think we will give the first team a little bit of time to get ready now, play a few videos. And then the first team, which is the base bunch, they were first. It was a random draw. So the order is completely random, but they get to go first. And I think let's cue the video and the base bunch will be back with their presentation.
Okay, so hello everyone, and to all the teams, good luck for the finals and congratulations for being here in the finals. To the base bunch specifically, it's been a pleasure working with you, sharing knowledge with you. Not, of course, just with you, all the other teams that I was mentor. It's been a pleasure to go from a competitor to a mentor and to be with you and to learn also with you, actually. So the best of luck. You've been doing amazing, so just continue doing that, really.
Energy poverty is a problem everywhere. In Ghent alone, 35,000 people are at risk, extending to over 50 million households in the EU. People are struggling to access the energy they need, putting them and their families' welfare at risk. We are the Bays Bunch, and over the past 4 weeks, we were challenged to use data science to identify inclusive energy communities to help solve this problem.
Energy communities are groups of people, households, and businesses that generate renewable energy, share resources, and collaborate in initiatives. They empower members to take control of energy consumption, reduce costs, and promote sustainability, for example, by sharing solar panels and trading electricity. However, the task of creating energy communities is not as simple as installing solar panels in the center of each postcode. We need an effective way to allocate and distribute energy equitably to those who need it the most. We consider 5 dimensions to define energy communities. We target areas where people are vulnerable to energy poverty, have lower quality of life measured by VIMD, are able to produce solar energy, have small communities, and houses that are close to each other. Today, we proudly present EcoMapper, a data-driven tool for city councils to establish new and inclusive energy communities.
Our product starts off with an easy-to-use Python package. This contains functions and instructions so that analysts can easily optimize their own energy communities. We've made this package with user experience and scalability in mind, where all you have to do is first choose your data, and this can be for any location. Second, you can set constraints for your energy communities. Here we're restricted to locations that are likely to be vulnerable to energy poverty, but also have a high amount of solar potential nearby. Lastly, you can pick one of our built-in optimization algorithms. A k-means clustering algorithm is our default. Next, we created an interactive dashboard, which creates and visualizes energy communities. A city planner, for example, could use this tool to propose potential energy communities. First, using the toggles, the planner would input social requirements, such as the number of communities, how close members should be to one another, and risk of energy poverty. Our integrated optimization algorithm will then quickly map the best communities. Here, the colored dots represent members of each community. The lines surrounding these represent the community that they are part of, and the black markers are the best locations for solar panels for maximal energy returns. This shows the user which locations would benefit most from having access to energy communities. Finally, you can see the summary statistics for cost, energy production, and existing infrastructure. These can help build the argument for investment and buy-in for energy community initiation, ultimately kicking off the process of providing renewable energy to those most in need. EcoMapper is a powerful tool, and we haven't stopped there.
Using an innovative reinforcement learning approach, we created a proof of concept to optimize the many elements of an energy community. First, we created a custom environment of undefined energy communities, in this case for the city of Ghent. The environment has actions, which consist of selecting participants based on our dimensions and grouping them into a community. Next, we define rewards and disincentives based on what we want to prioritize. Here, the priority was set towards including areas of a higher deprivation index. Lastly, a neural network agent will learn the sequence of actions that creates the communities which result in the greatest overall reward, producing a series of proposed communities like the ones mapped here. The design will allow the user to alter the reward systems and place importance on their chosen dimensions, making it flexible to their city's needs.
EcoMapper has the potential to deliver real social, environmental, and financial impact. Forming resilient communities will help mitigate the impact of rising energy prices and climate variability on people's health and everyday lives. This improves emotional well-being and protects the most vulnerable groups, such as children and the elderly. Creating these communities also helps by increasing the share of renewables in Belgium, contributing to their energy targets and helping to cut household emissions and energy bills. EcoMapper is a catalyst for change that can be applied to other cities and countries. By leveraging data, technology, and community collaboration, it will transform the way we consume and produce energy, uplift society from energy poverty, and adapt to climate change. We're the Bays Bunch. Thank you for listening, and we now welcome any questions.
Perfect. Thank you so much, Bays Bunch. Right on time with 10 seconds to spare. So I don't know whom from the jury would like to kick off the questions. Not maybe Joyka, or Stefan, go ahead. Yes, perfect. Thank you for volunteering.
Happy to volunteer the first question here, and thanks so much for the presentation. Extremely insightful. So one question I have is, who is the audience of EcoMapper, right? So who did you design the EcoMapper interface for? And yeah, that's kind of my first question to get started, in order to understand whether, anyway, you have an understanding of, anyway, who's the persona that you seek to serve there?
I think
yeah, I don't.
Okay, sorry, I think Sam jumped in, but I had technical issues. Yeah, so the audience or the user of the tool, we envisage mainly as city planners or decision makers within the local governments, or those who are looking into the projects of defining energy communities or general infrastructure that would support inhabitants. So we, I guess, to be more specific, we imagine not necessarily a data scientist or a technical user, but someone with a good deal of subject matter knowledge in their city. And I guess together with the tool, we'd hope that they'd be able to propose some good energy communities from that.
All right. Who would like to go next?
Yeah, I'd like to get some more information about what you showed the way of using the tool, and then you spoke about in the middle about the rewards. Could you go a little bit more deeper into how you conceptualize these rewards for building these energy communities?
Yes, sir. I think that was me again. So I guess there's two parts. Then the initial tool, the part that is ready to go now, is first of all selecting the overall population that you would consider for these energy communities, and then just creating the communities based on their spatial closeness, so using clustering. The second part, and where the rewards come in, is our, I guess, more advanced solution that isn't fully integrated into the dashboard yet, but that is the aim, is to use reinforcement learning. And one of the key aspects of reinforcement learning is that an agent will learn to make certain decisions based on, well, the reinforcement it gets, either positive or negative. So the way we envisage using it is to reward communities that meet certain goals. So the example we'd use is we would reward inclusion of more people likely to be facing energy poverty, and also things like spatial closeness, and I think also small clusters were mentioned. So this is basically to give the user control over the priorities. We have some defaults which we set for our initial proof of concept, but the idea is basically to think of rewards as priorities for the city.
Okay, I understand. Thank you.
I'll just jump in. Additionally to that, when we ran the reinforcement learning, the communities that were formed that came out as the output of that, over 90% were ranked under the average for that they were more deprived areas. So we're trying to target the right groups of people that we want to help with that, basically.
All right. Maybe Lambert.
Maybe if I can jump in. I had a question that actually relates a bit what you were talking about right now. My question was, how do you measure your impact? How do you measure whether these communities are really effective and complement each other and can support each other? And that measurement, I guess, would be what you need for the reinforcement, right? So that's my question. How are you measuring the success of your algorithm?
Happy to have a go. So to evaluate the impact of the resulting communities of our algorithm, one of the rewards could be how fairly widely distributed the people who are vulnerable to energy poverty are. So we don't just want clusters of people with really low income, but we want to spread them out across the clusters. We also want to even out a balance between the supply and demand of energy. So we could reward the balance between energy demand and energy supply within each clusters to make sure there's not too much excess or too much deficit.
Mm-hmm. Yeah, that seems like a good idea. Well, I think you have a really sophisticated way of looking at this, and I think adding some of those metrics in there that will help you measure impact and then reinforce the process. That would make it an even better solution. So yeah, congratulations.
Perfect. Any Stefan, Joyka, any other question?
I'm wondering, meaning, having lived in Ghent, it's a pretty cloudy city, and so wondering whether you've looked into other variables, meaning you looked into, and so what were those variables that determine access to alternative energy sources such as solar energy, and whether that is part of the model that you're building. So trying to understand what are other data sources that you're looking into that may inform communities about the feasibility of actually generating energy on a sustained, not just renewable, but also sustained approach.
And jumping quickly, one of the tools that we looked at when we started working on this was Google's Sunroof API. We really like that idea of being able to see where things could be and also show the user, i.e. City of Ghent worker, community planner, what the actual projected irradiance numbers are, how much energy they can potentially generate through the solar systems. That's something we'd be really keen to put in through maybe a collaboration like that.
I think also to add on to that, so I think for the current iteration, in terms of the energy production and so on, we've only considered the available data, which does take into account sort of solar irradiance at that time. So I think one of our assumptions that this would be representative, I guess, throughout the year, which would be an oversimplification. But I think, yeah, the next step would be considering possibly other climate and weather variables into that. But I think we would, yeah, we'd face a challenge of differentiating areas of Ghent in that. But yes, definitely understand the challenge coming from Scotland as well. Yes, sun is not plentiful.
One more point I would add is we see it quite straightforward to adapt our tool for wave or wind energy or other renewable energy sources, but not in terms of energy production. So I don't think it would be easy to install wind turbines across the city, but we would then adapt it to where the best locations to store energy. So it's generated somewhere else, but where should we store it and then most efficiently distribute it across the clusters? So we would reuse a lot of the same technology as well.
Right. Any further questions?
Not really. I would like to add that I was really very pleased by the low threshold for using it, not being very smart on data and technical issues. I kind of was very charmed by the way it was presented. So I think maybe I could understand and use it as a tool. So I think that I wanted to say that as a compliment to the base bunch.
All right. If there are no further questions, I think, Base Bunch, I would like to thank you for your presentation. And I think now it's only the waiting game for you until we know the results. And after a short video, we can already also start with the next team. Thank you so much.
Hi everyone, my name is José Vieira and I work at the Center for Artificial Intelligence and Analytics in Fidelidade Group. The insurance sector is full of data science challenges, such as classical supervised classification models for customer cross-sell and churn propensity, as well as deep learning and computer vision exercises, such as intelligent document processing, car damage assessment in either pictures or video, or even topic and sentiment analysis in either text messages or phone calls. All of these projects are built by our internal teams at the center. If you'd like to know a little bit more about our projects, feel free and reach out. I wish all of you a wonderful World Data League. Best of luck.
Fidelidade, so that life doesn't stop.
Hi, Insight Squad team. As we enter the final round, let us reflect on our journey, the challenge we've conquered and the bonds we've formed. Embrace your brilliance, trust in your abilities, and let this stage be where you shine. Good luck.
Hi, we are the Insight Squad team. We are delighted to present our work on the challenge of inclusive energy communities proposed by the World Data League and the City of Ghent. 51 billion tons is the number of greenhouse gas globally added to the atmosphere in a typical year. When we break down this number into sectors to see major contributors, electricity is the second category in the greenhouse gas. Energy communities may pave the way to reduce our ecological footprint. Our proposal for defining energy communities in Ghent centers around three main points: renewable energy production sites, the energy consumption, identification of the residents that are vulnerable to the energy poverty. The solution went through several phases, with the first one being gain a better understanding of the available data to extract valuable insights that can support decision-making process effectively, like areas with potential green energy production and areas with lower income per capita. In this phase, we gather data from several sources that contain location information in some form, and we attempt to add the reference of Ghent sectors that those data were associated with. Then we develop a cluster model to group Ghent sectors that can share a similar strategy and energy community programs. Lastly, create a user-friendly front-end interface where users can access and explore the generated graphs. Additionally, providing them with a calculator tool that estimates the potential impact of installed solar panels on their rooftops. By accomplishing this milestone, we have paved the way for a more data-driven and inclusive approach towards energy communities in Ghent. During our project, we undertook the task of creating a sector-oriented data set encompassing key information such as income per capita, energy consumption, renewable energy potential, demographic data, and we also create an extra feature that represents the vulnerability score for each sector. This data set serves as an input to a clustering model, enabling us to group sectors with similar needs and potentials. For that, we use optics model. As insights, we create a heat map with multiple layers that allow us to visualize indicators by sectors, such as income per capita, energy production, energy potential production, and the relation between the consumption and the potential production. Also, several bars and line charts that characterize the energy consumption and production of Ghent. Then, using the vulnerability score that we define for each Ghent sector based on the incoming and the population density, and for the top vulnerable Ghent sectors, we create a vision of several features for each sector. Here's a map that we can use to identify the most vulnerable sectors. The marker color represents the incoming per capita and the size represents the population density. Then we come to the cluster model. We aim to find the algorithm that would allow for flexibility in terms of the number of clusters and then the capability to identify sectors that were similar in the close proximity. Finally, we create a front-end dashboard with the main insights that can be used by the Ghent City Council and an environment calculator that quantifies the positive impact of the solar panel installation in the environment and that can be used by the general public. In terms of impacting, taking in consideration that Ghent potential energy production is almost 1 billion kilowatt-hour, just by installing 30% of the identified potential equates to the impact of one of these four metrics in terms of carbon emission, passenger car, tree seeding, or incandescent lamp switch to LED. Our solution is capable in data analysis. Our solution is scalable in data analysis, allowing it to work in large cities with similar raw data. The optics cluster algorithm automatically detects cluster number, making it capable for large-scale problems. And our environmental calculator is versatile, customizable to factors like sunlight hours and energy cost, making it perfect fit for any energy community needs. Thank you.
Thank you so much, Maria. That was a great presentation, and you had, I think, 15 seconds left. So again, on the dot, see everyone came prepared. So yeah, to the jury, who wants to start with their questions?
I would like to start. You went over a bit quick, but I was triggered by the way that you said it could be used by the general public. So is that correct, that if I am a citizen, I could use your online tool or the way you present the data to see if I can make a energy community with my neighbor?
Yes. Let me show here. So the calculator. Are you seeing my screen? Yes.
Mm-hmm. Yes.
So we construct this calculator where we can choose here a city. So we put here the city of Ghent. We have here the cost of the energy, and then we put here the square meters of the roof, and we can calculate the impact of the installation of these solar panels. So the general public can use this calculator to quantify how much he will not pay at the end of the month, and which will be the impact in terms of these 4 metrics.
Just to add, there's also given a recommendation of the solar installation size, so the person has a better idea of the needs for their specific case.
Okay.
I have a question, and again, thanks for the presentation. Given the fact that the focus is on energy communities, so I'm trying to see how would I understand what kind of communities can be created using your tool.
We try to aggregate the data as the sectors of Ghent. So we try to translate all the data that we have in terms of locations to each sector of Ghent. We have the polygon that defines each sector, and we translate, for example, the consumption that are in the street level, and we translate them to sectors. For example, we see all the buildings that are on that street. If the street goes through several sectors, we try to quantify how many builds are in each sector of that street. So we translate to the consumption that are reported in that street to each sector, and we try to identify the sector that are more vulnerable, and our definition of community will be at the level of the sector. So we try to modelize everything in terms of the sector of Ghent, each sector of Ghent.
Yeah, so the sector, basically, we chose this to kind of simplify the problem, and then with the clustering, we can identify sort of priority sectors to act upon with the same needs, basically.
Thank you for the questions and answers. Are there more questions from the jury?
Well, sorry to go on this point, but I still don't quite understand who creates the communities. Is it officials from the city of Ghent, the local administrators who use the dashboard and identify these communities and assign the communities, or is it self-organized by the citizens?
It will be in our mindset, which will be the Council of Ghent. They will see which sector are similar by the clustering model, and it can pick one that are similar, make a pilot, define a strategy for that pilot, see if it's work in that sector, and if it's work, it can apply to the other sectors that are similar.
Okay, sometimes I think you want to get people together who are not similar, right? People who have an energy deficit and people who have too much energy, and put them together in a community, right? So they can support each other. Would your dashboard allow city officials to identify those kind of opportunities?
Since it's the community will be inside in a sector, and inside in the sector we have several types of persons with vulnerability and not. Yes, it comprehends that situation, but we have the feeling that we want to detect the sectors that are more vulnerable. This is one of. Okay.
Yeah. Very good.
Right. Are there any more questions from the jury?
So yeah, so can you remind me again the data, the indicators of vulnerability? Meaning, so what were kind of and poverty? What were those that you were using?
Okay, yes. For the vulnerability score, we use the density, the population density, and the incoming. So the sectors that have more density, we will contribute for a more vulnerability score, and the sectors with the lowest average income will also correlate with a more vulnerable score. So we try to identify the sectors that have less incoming and a higher population density to identify that sectors. And if we look to this map and we see the red circles with a huge size, then we identify them as the most vulnerable sectors to create the community as a priority.
Well, it looks more or less correct, I think, on site. So I'm coming back to my earlier question. So what Stefan was, or I think Lambert was asking about how you choose energy communities. It's not possible to do it with the tool itself. So with the tool itself, you focus on individual households and their needs for solar production and
we have a part that are for the city council, okay, where they can detect the results of the clustering model, and they identify the clusters, the sectors that are similar, and define for each group a strategy, a different strategy, depend on the needs of each sector, define a sector as a pilot, and try to make that strategy work. And we had another tool that is the calculator that can be used by the general public to see if they are interested in making installation of a solar panel. And that calculator can sensibilize the person to make the installation. It's only for that.
Okay, thank you.
All right. Is there another question? I love the reaction of Joyka just there. Yeah, that looks accurate. I think this is the importance of domain knowledge in one moment. So that's why it's so great to have someone who is part of the city of Ghent and two jury members who either live or have lived in Ghent. We have time for one more question, if there is one.
Wonder whether you also take into account the cost of investment for building communities, and again, it goes back to what Lambert, I guess, was saying as well, is that, you know, is there a way to think about redistribution of cost by combining communities that are better off and worse off, and so whether this is something that you could figure out with your tool.
When we look at our clusters, we can sort of see the differences in what make each cluster its own. Like we can see if there's a cluster that has a better balance of production to consumption and mix that with income. So we can sort of see which sectors in clusters can serve as helping sectors to others in need.
Great.
All right. I think with that, we'll call it a wrap. We let you off the hook. I know this is the most stressful part of the questions. You can prepare the presentation, but not for the questions. So great job. And I think we're going to play a few short videos and give the next team time to prepare to get on and be ready. Thank you so much. And you also will have to wait.
Hi, everyone. My name is José Vieira, and I work at the Center for Artificial Intelligence and Analytics in Fidelidade Group. The insurance sector is full of data science challenges, such as classical supervised classification models for customer cross-sell and churn propensity, as well as deep learning and computer vision exercises, such as intelligent document processing, car damage assessment in either pictures or video, or even topic and sentiment analysis in either text messages or phone calls. All of these projects are built by our internal teams at the center. If you'd like to know a little bit more about our projects, feel free and reach out. I wish all of you a wonderful World Data League. Best of luck.
Fidelidade, so that life doesn't stop.
What a ride! It's been my pleasure being your mentor at the World Data League and discussing your ideas already on that first phase and now again in these very intense finals. You've put in the work, so now all I can say is best of luck.
Hello, we are the AI Wonder Girls, and we are happy to present to you our pitch today. We're an international all-female team from India, Spain, Indonesia, and the USA. This is Fatma. She's 41 years old and a busy mum of 3 living and working in Ghent. She struggles to make ends meet sometimes, and she's been shocked at how high her energy bills can be. She's sure there must be a better way, but she doesn't have the time to look into it, and she wouldn't know where to start. Like 1 in 3 of Ghent's residents, she's also from abroad. She's Turkish, and she's not sure her Dutch is good enough to deal with technical matters like this. Then one day, someone sends her a QR code. It links to a web app called Zonnevisie, or Solar Vision, on the Ghent City website, explaining that she could save on her energy bills and reduce her carbon footprint by joining an energy community. What's more, the explanation is in Turkish as well as some other languages. She puts in her address, and the app shows her an energy community she can start up with some of her neighbours, tailored to her household energy consumption and showing how much she could save. Sustainability is a big priority for Ghent, so much so that it won Europe's 2018 Transformative Action Award for Sustainability. Energy communities are one of the most important means of reaching its goals, and in the current economic climate, they can also play an important part in reducing energy poverty. Although 20% of Ghent residents have solar panels on their homes already, research in other parts of Europe shows that these people tend to be older, wealthier, and more educated. How can we help people like Fatma not get left behind? Our custom-made optimization algorithm groups residents in Ghent into clusters that we propose can form an energy community together. And we recommend locations where they can install solar panels too. Our recommendation tells them why they should join and points to resources to show them how to join, breaking down the barriers to get started. For Fatma, this means she knows who to contact and how to talk to her neighbours about setting up an energy community, and she can receive all the help that Ghent offers. What makes a good energy community then? Based on academic research about what makes energy communities successful and fair, we identified 4 key performance indicators on which to optimize them. Our machine learning optimization algorithm finds the best way to group households and solar panel locations to maximize profitability, to keep startup costs low, to allow low-income households to take part, and to keep energy communities local. Our background reading shows that small local communities increase social cohesion, a secondary benefit in addition to alleviating energy poverty and reducing carbon footprints. Why these KPIs? Well, they can be modified. If Ghent decides they want bigger energy communities, or they want to include the socio-economic diversity of members, these can be added or reprioritized as needed. It's not just Ghent, but any city that has data on solar irradiation and energy consumption can run our model too and get recommendations. And then there's the business model. We assume that our energy communities are cooperatives, but this is something that can be reconsidered as well. In cooperatives, everyone invests an equal share and everyone sees the benefits. This reduces economic inequalities, but it requires everyone to have access to startup capital. In fact, our modelling revealed some important insights about startup capital for the city of Ghent to consider. We already knew this, but energy communities are not always profitable. Optimising the size, composition, and location of energy communities is really important. The biggest determinant of how profitable it is how much capital is put into installing solar panels. This can be a problem for those in energy poverty because they usually have the least capital to begin with. In order to make energy communities work in a fair and financially sustainable way, Ghent will need to think hard about how to ensure everyone has access to startup capital. In the Flemish city of Eeklo, for example, shares in the EcoPower energy community are pre-financed for people in energy poverty. So what's next for Fatma? Armed with the information from our app, she starts talking to her neighbours. With cold hard numbers, it's easier to convince them to give it a try. Together they contact the city of Ghent, which supports them in installing their solar panels. Not long afterwards, Fatma is a happy member of a local energy community. Electricity bills down, carbon footprint down, social cohesion up. Seamlessly integrated into Ghent's initiatives on climate action, our web app can encourage any resident to become a member of an energy community. When the self-sufficiency rate increases, Belgium will meet its goal for affordable, reliable, and sustainable energy. Expanding to the world will beat climate change, and Fatma will see her household bills that much easier to manage. Thank you for listening.
Perfect. Thank you so much for your presentation. And now we can start with the question from the jury member. Maybe Lambert, have you gone first before? I don't think so.
Sure, happy to start off. Thanks, Emma, and all the rest of the team. It's really well presented, and I love that you took a concrete persona that makes the story very, very concrete and imaginable. I like a lot that it is a web app that everybody can use. Could you tell us a little bit more about how it works behind the screen? You said you have a machine learning algorithm that finds the optimal ways in which these communities get created. But of course, residents will log on to the app at different times, right? Maybe somebody else in the same neighborhood will log on a month later, etc. So can you explain a bit how that algorithm would work?
Yes, the idea is that the algorithm is run once. I mean, of course, it can be updated every so often if the residents change significantly. Maybe you want to update it once a year or something like that. But the idea is the recommendations are produced once. We did this based on the historical data about solar irradiation in different areas of Ghent and the energy consumption of people, well, households as we assume them to be around Ghent. Based on this, we trained 3 models and selected the one that worked the best in order to cluster together so that every resident of Ghent would be in one cluster with 1 or more solar panels to optimize the KPIs that we mentioned. And the idea is that this is the kind of fixed recommendation. So whenever a resident goes onto the app and enters their details, they can see what's recommended for them, who they should partner with to form the energy community, and what benefits it can bring them.
Okay, thank you.
Thank you. Who wants to go next?
Yeah, I would like to. That was a very interesting question by Lambert, and I would like to ask if there is a possibility. You set the KPIs and you make the system work. By the way, I really like that you had some attention to different languages and really usability for people really actually living in Ghent. So thanks for that. But I was wondering if you could make it more learning, like about what energy communities were already started. So now you are a little bit static on it's just a step further. I know it's already great, but now you're very static on what's possible. But could there be a way to like celebrate successes or put in information about existing or energy communities that started along the way? So maybe that would be valuable information for users.
Yeah, it's a good point. We did think about this. We didn't have sufficient information about the energy communities that exist. I mean, we didn't have anything as granular as which households already belong to them. So we couldn't include them in the modeling that we've done. But we would completely agree, I think, that it would be an important next step to add to the solution.
Yeah, definitely the solution can be scaled to include these other data points. And yeah, we can definitely do, it can definitely be scaled to include new data points.
So I have a question on how do you identify your community members, and whether that requires and would be a challenge from a personal data perspective, because that's kind of one question that I've had is that is this going to be a GDPR nightmare to even identify your community members that you could create a community with, right? Because it's pretty granular the way you go. And so have you thought about that? You know, GDPR being the data protection regime in Europe, under which Ghent has to comply with as well.
So one answer to that is you don't particularly get information about your neighbors when you put in, even if you put in your neighbor's address, it doesn't say your neighbor's energy consumption is currently this. You can also somewhat scramble the numbers as well to anonymize it a little bit further. Essentially, that's what we did because, of course, for the same data privacy reasons, we didn't have access to every household's individual energy consumption. So we can somewhat abstract these very fine details away. I'm no expert in GDPR, but I would imagine that you can apply similar protocols to ensure that it's all within the regulations.
Yeah, so during the data collection, maybe we can add masking or redacting the data before we actually pass on to the feature engineering or further modeling.
Any other questions? No? Going once? Going twice? All right. Then thank you so much. Thank you for, well, first of all, again, thank you for these nice questions and thank you for answering the question and presenting. I wish you good luck in the outcomes. And I think now we're ready for the next team. But before that, we'll just watch a couple of videos while the team does get ready. See you in a bit.
Hi, everyone. My name is José Vieira, and I work at the Center for Artificial Intelligence and Analytics in Fidelidade Group. The insurance sector is full of data science challenges, such as classical supervised classification models for customer cross-sell and churn propensity, as well as deep learning and computer vision exercises such as intelligent document processing, car damage assessment in either pictures or video, or even topic and sentiment analysis in either text messages or phone calls. All of these projects are built by our internal teams at the center. If you'd like to know a little bit more about our projects, feel free and reach out. I wish all of you a wonderful World Data League. Best of luck.
Fidelidade, so that life doesn't stop.
Hi, Sir. It has been a really good experience to mentor you through this final stage. Of course, in my opinion, which may be biased, you've done a great work, and I wish you success for today.
Hello, everyone. We are the team SEOs, and we set ourselves to solve the challenging problem of creating energy communities inclusive of residents vulnerable to energy poverty. That has been a trending topic as the world faces a severe crisis with energy prices reaching record highs, which is leaving plenty of families in vulnerable and in poverty conditions. However, new initiatives that accelerate the adoption of sustainable renewable energies have emerged, as well as investment in energy production infrastructures to better serve local communities and reduce inequality. This falls under the 3 Sustainable Development Goals defined by the United Nations to use affordable and clean energy, reduce inequalities, and create sustainable cities and communities. The City of Ghent has ambitions in order to reach these goals, as they intend to inaugurate energy communities with shared solar panels, which is proven to be an effective way to allocate and distribute energy in an equitable manner. But this is no easy task, as there is no clear definition of what an ideal energy community is, especially because it depends from city to city according to their inherent characteristics. So, in our solution, we propose a tool based on an AI optimization algorithm that indicates how energy communities can be formed, mitigating this unsustainability of current energy production and energy poverty. Basically, this is just the perfect definition of our product. Our ready-to-access website interface is designed for the city planners, social services, among others, of any city interested. The user starts by inputting the social and energy data. To accommodate different cities' needs, the website and the user can customize the different features they find more important for a community to have. Depending on the weights given, an optimization of the city arrangement will be generated via a clustering method. And what we get is a result is obtain a map with colors identifying the various communities formed and an energy balance graph indicating the savings for each community, a useful marker to explain how we are fighting this energy poverty. But the remaining question is, what parameters does indeed our website take into consideration, and what does the user can adjust towards their city? As an energy community aims to foster socioeconomic diversity, we use the households' rent prices and the average incomes to ensure communities have a socially heterogeneous demographic. We've also accounted for the proximity of the houses, as these communities need to be geographically compact. And certainly energy data is fundamental to be included, both the average energy produced by a building with already installed solar panels, for example, as well as the electricity consumption rates throughout the city. Ultimately, the data that binds all these elements together is estimated energy, the estimated energy that can be produced by each building's future solar panels and how this could contribute to the community. Taking, for example, the use case of the city of Ghent, we can study what would happen in case the buildings within the community are close together and the buildings with high sun exposure are paired with people with lower solar opportunity for them to share and create an equitable energy environment. But what if you want communities with socioeconomic variability? Then we can increase the importance of income diversity, for instance, and reduce the potential to install new panels, which results in the city being reorganized differently. By analyzing the energy balance on each community, we can see that although the number of houses varies, represented on the green bars, the estimated energy to be distributed is always lower than the consumption. So here the ratio between the orange and the blue bars, meaning that no new energy is being returned unnecessarily to the grid, and it helps save at least 30%, which is obviously a great help for people facing energy poverty. In summary, our product is able to use data from any city and generate layouts according to what the city planners agree is the best trade-off, helping to shape the entire city energy grid towards a more sustainable future. We expect that a solution like this will motivate and increase the creation of energy communities by outlining their obvious energetic advantages. These, coupled with ongoing trends, will mean an increase of at least 16% of renewable energy usage per year. And as seen before, this information can guide city planners to unite communities and houses to decrease their energy household costs by average 30%, relieving people facing poverty situations. Finally, I cannot live without mentioning this amazing group of friends, Mariana, Ricardo, Anne, and Mariana, where you all believe that champions can engineer neuroscience. We are Seos, thank you, and I'm open to all your questions.
Thank you for the great presentation, Duarte. I just, in the moment where you ended, I gave you the 30 seconds warning. So,
okay. So
you
perfect.
had 30 seconds left. Perfect. So far, all the teams have made it under 5 minutes. Yeah, no, great presentation. And my question for the jury, who wants to go first?
I will want to go first.
Okay.
I was wondering, so if I understood correctly, you divided into 8 communities, the city of Ghent, with your data sets, and
exactly.
these 8 communities can vary in scale and proportion and how they are constructed due to your 6 correlations there. But do you think this is small enough to so your users are local government people like me or my more technical colleagues to look after energy communities, but can you go to a small scale and a scale that's small enough to identify specific areas where to start an energy community? I'm a bit concerned about that because this map doesn't give me at this moment, but I have a small screen now and I'm not using it. Can you reuse it to identify a street or a cluster of streets where to start?
So that was actually a conundrum we had in the beginning of the challenge, as we were talking with the city of Ghent about for example, the radius of an energy community. This can be very distinct. And so we decided to make an approach more longer term that can influence the whole city. Of course, in our website, you can define how many communities you want, since we are using clustering methods. So if you say, for example, we want 20 communities, of course, the radius is going to be smaller because we are taking consideration the whole city. Okay. But our big advantage is that in the future, you want to reconnect and reestablish different connections between the city energy grid and how these houses share energy and share electricity. So I think by creating these big clusters, we can have a clear notion of how we can save energy and make people's life better and less poor. I don't know if it answered exactly what you wanted. So yeah, we have that flexibility in our platform, but that's not our main goal, I think.
Okay, thank you. But we can use it at local government.
Yeah, so
your main target for users is like urban planners and people. Yeah, okay,
so they
thank
know
you.
which houses to connect, how they could be connected, how we can evaluate this diversity between people with high income and low income, so they can live in equitable shareage of energy, or with buildings with a lot of exposure or less exposure. Yeah, we can balance these out with our score and our optimization. Yeah.
Okay, thank you.
No problem.
Thanks for the question and answer. Who wants to go next?
I have a question about the picture that we're seeing here. And it seems that some of the communities that you identified there are sort of geographically contagious communities. Like the pink one and the orange one, they're sort of coherent geographically. But then some, like the red, I see a number of red dots within the gray area, and it's a bit mixed. And what are your criteria in terms of keeping them geographically together or mixing them and dispersing them? How do you?
Yeah. So for example, in this slide, we have this relation of weights and importance. Of course, if we maximize the weight of proximity and we make it a scale even higher, the communities will, this kind of appearance of houses being scattered and communities being almost merged within one another would disappear, okay? But this was the optimization we decided. We thought it was a pretty map, so we decided to put it. But yeah, so answering, since we want to evaluate and want the city to have the best energy, let's say, balance and ratio, this was the best model or the best map that it suggested. If you, for example, our city planner says, no, I cannot have houses mixed with each other, communities mixed with each other, because that's a mess on energy lines, for example. But you can increase even more the weight of the energy of the proximity of the houses, and that solution will be given. So it's totally to the city planner and what they feel the map is good enough or it's not good enough, and they can tweak how they prefer and like.
Yeah. Okay. Very good.
Yeah. Would you have
yeah,
any other
question on the map. So there are areas on the map that don't have any color, right?
Yeah.
And so I'm trying to understand. So they don't correspond with any of the indicators. I mean, I'm just trying to understand why.
So, for example, here it's a park. There are houses that we didn't have information about, so we could not put it on the model, let's say.
All right. Okay. All right.
So we use all the information. Yeah,
okay.
It was more a data constraint than anything else. Yeah, but we're actually in like parks, big areas that do not have big buildings. But you see that mostly the center of Ghent is fully occupied.
Right. Yeah. I was just wondering because.
Yeah, that was a data constraint issue. Yeah. So of course this is scalable. So any city, as long as we have the data formatted for all the buildings, all the energy and social data that we intend, which can come from census, for example, that we do every 10 years. But it would be a good enough estimation and approximation to what a community could be organized like. Yeah.
And so remind me again, what are your criteria for impact? I mean, how would you declare success?
So that also depends on the city planner. I can show you here one of the graphs was from the community or the set of communities we were just showing. Here we have the electricity consumption versus how much production we will have in the future if we implant the solar panels, okay? And we can see that the orange almost covers all the blue, which is meaning that people and communities will have a new source of energy, and they do not need to spend their money buying energy from the local energy giver or energy supplier. So they will save a lot of money since they are redirecting their energy use for a renewable solution. We are assigning the cluster 7 since it's the biggest distance, which only about 30% of the energy is being renewable, and the rest is not. But you can see that most of the other communities, like the 2 and the 4, it's very close. Yeah, that's it. And I'll give you a note. This is because we decided to optimize for this. If we optimize for socioeconomic diversity, this may not be the case, but we will ensure that the people is more diverged, where inside the same community we have people with high incomes and with low incomes, but they share the same environment. So overall, the average is going to be the best for everyone. Yeah. It's literally the most flexible, adaptable solution that the city planners and the urban planners can use to really tweak and trade off what they really think is the best for their city.
And do you anticipate even a participatory element of it? So, because the urban planner seems to be, but anyway, can this map be used for a public conversation about communities, for instance?
You mean bringing it to the people and showing people that are living in Ghent, for example, how their house would improve or beneficiate from this kind of solution? Yeah, of course. So
yeah, they can. Yeah, I'm just wondering because it seems like a lot of the criteria are delegated to the urban planner to decide what their priorities should be. And so the question is, can you use it as kind of a public conversation?
Yeah. So for example, this plot area here,
and you would have that.
Yeah, the orange and blue bars are per house. So per house inside the community. So if you present, of course, not as complex here in the data science environment, but if you show someone that they spend 1,000 kilowatts hour in a year, and if you put a solar panel in the 3 houses next to it, you'll save 80%. I'm talking about the cluster one. You'll save about 70 to 80% of their electricity. Of course, they'll be very pleased and will want to continue to learn about this and to maybe integrate in this new community. Yeah. I hope it answered. But yeah, I think it has all the potential to first be used by city planners for them to decide what is best, but then bring it to the people for them to make the last choice and the last decision if they really want to enjoy and avoid in this ship of energy savings and lowering energy poverty and more sustainable cities. Yeah. Thank you.
All right. I think if there's another question, we have time for one more.
I've been talking. I don't know if anyone else in the team wants to say something. Here in the Zoom with everything shared is a little bit difficult, but be free to intervene whenever you feel like, of course.
I was curious about your first value proposition here, how this actually works. No produced energy is returned to the grid.
So,
yeah, it somehow came surprisingly here after all of your other slides, but maybe I missed something.
No, it's super fine. So if you look at all the orange bars, they are lower than the blue bars. Okay. So that means that the new solar panels, all the energy that's being produced by those new solar panels will never go to the grid because it's being used by some of the houses or is going to be distributed by the houses and it's never going to be wasted, let's say. There's no spare energy left. Okay.
Okay, so that's an assumption for if you use the map right.
Exactly.
Actually,
exactly.
yes.
Exactly.
Okay.
Exactly.
Thank you.
Yeah. Okay.
Okay. Thanks again for your presentation and standing all the answers. Said it with the last team. I know this is the stressful part, and all teams so far definitely have done great. And I think we will play a few videos to give the 5th team time to get ready. And yeah, thanks again.
Thank you again so much. Thank you, the jury.
Hi, everyone. My name is José Vieira, and I work at the Center for Artificial Intelligence and Analytics in Fidelidade Group. The insurance sector is full of data science challenges, such as classical supervised classification models for customer cross-sell and churn propensity, as well as deep learning and computer vision exercises, such as intelligent document processing, car damage assessment in either pictures or video, or even topic and sentiment analysis in either text messages or phone calls. All of these projects are built by our internal teams at the center. If you'd like to know a little bit more about our projects, feel free and reach out. I wish all of you a wonderful World Data League. Best of luck.
Fidelidade, so that life doesn't stop.
Hello Data Warriors, I wanted to congratulate you for your work so far during the World Data League 2023. As students, you had to learn a lot of new things during this phase, and I was quite impressed with your outcomes so far. I really enjoyed getting to know you, and I wish you the best of luck for this finals phase.
Good afternoon. We are now going to present our project on energy communities. We are the Data Warriors, and our team is composed by myself, Clara, João, and Madalena. These are the topics we are going to talk about. We'll start with the context, objective, and clustering, and then the product, impact, and the next steps. Since the other teams already spoke about this, we'll give a very brief context. As we all know, their energy prices are rising, which pushes more residents into energy poverty, and energy communities are an effective way to get around this problem. Going into this project, we had some objectives we wanted to achieve, like finding solutions to secure energy for the most in need, analyze Ghent's potential for energy saving measure, and compose energy communities that generate environmental benefits.
Our solution was based on SDG 7 that is related to sustainable energy. And basically, we had spatial data regarding streets in Ghent, and we wanted to group them based on a metric that was related to the rent of each street, the value of the rent of each street, and also the energy consumption. So it's the percentage of the rent price that pays for the energy consumption. And with this, we built a very simple but scalable model that resulted into 3 clusters, 3 communities. And with these communities, we could see many benefits. For example, as you can see in communities 1 and 3, we could save a lot of money on energy prices. For example, a community 1 saves up to 71% of this price. That corresponds to actually 13 times the annual salary in Belgium. And also, for example, in community 2, we can see that the metric that we created also decreased based on the street that was spending the most money on energy and the mean of the community. We also tried to develop a complementary optimization algorithm with 3 clusters.
So from the clusters that we created, we decided to develop a product that was an energy dashboard to help the users evaluate their energy situation and to evaluate the benefits of joining one of the communities. So our dashboard would work in a very simple way. So in 4 easy steps, the user would indicate their postal code or their street to then see the community they are in according to the clusters that we created. Then the user would be able to check the community scores in terms of energy consumption, the energy storage, and also the metric that we created, the percentage of rent. And then the user would be able to compare the results of the community and to the results of their street by itself that they would have. Here's a very simple mock-up of the dashboard. At the top, the user would be able to select their postal code and then be assigned a community. They would be able to see the values of their street in terms of the money spent on energy, the percent rent assigned to energy, and the capacity, then the community values and the impact of joining the community. On the right, there's a map where the user could locate the community and see which streets belong to their community. And at the bottom, a very simple bar chart comparing the rents spent on energy of the community and of the street by itself. So based on literature in the area and similar projects, we could assume that these could be achievable results of increases and decreases in these fields. These would also be expected to achieve if the street or the person would join the community and if the people would adopt some sustainability measures and sustainable measures to even increase more the benefit of joining the energy communities.
Last but not least, of course, we have some future steps that we could apply to this solution. The first one would be to expand metrics and analytics, so we could incorporate other metrics more related to energy self-sufficiency or carbon footprint reduction. Then we would also suggest to try to use other clustering techniques. Our model was really simple, so we could definitely investigate more on hierarchical or density-based or even fuzzy clustering, and also other optimization algorithms. And finally, we could definitely expand this to other cities in order to walk together into a greener and more sustainable future. If you have any questions, feel free to ask, and thank you.
Great presentation, thank you. And also with 5 seconds left, so all teams made it in under 5 minutes, which is not an easy task, as anyone who ever had to put a lot of work into 5 minutes knows. So great job to everyone there. And now to the jury, who wants to go first?
I can kick it off. Great presentation, guys. I really like how you thought about creating something visual for the community to see the benefits of energy communities and encouraging them to join, giving them a reason to join. I think that's very important. I have a question about the main metric that you're using is, from what I understand, you divide the energy uses by the rent, or the other way around. And I'm just, I'm not a social scientist, but I'm wondering what you're measuring here. If you take the rent and the energy usage, people might be using much less energy because they can't afford to, right? They might be turning off or turning their heating much slower than they would like to because they can't afford the energy bills. And it's not totally clear to me what you're measuring when you divide the energy users by the rents. And another question that I had is, at some point, I think in one of your first slides, you said that the estimated savings that we can achieve is 99% of the energy usage. And that number sounded a bit implausible to me. So I just wanted to ask if I misunderstood that, perhaps.
Thank you for your question. I think I can answer it. Regarding the metric, basically, we wanted to take into consideration both the prices that people were paying. So because this is a spatial data set, so we wanted to see for each street what's the mean of the rent prices, but at the same time, the proportion to energy consumption. And basically, so a percentage, it was the first thing that came to our minds. So we thought about seeing the proportion. So how much percent of the rent prices corresponds to the energy consumption for each street. And basically, to answer your second question, yeah, it may look really high, but what we assumed was basically, for example, in this community, maybe there was a person that was spending a lot of money on energy, and not a person, sorry, a street that was spending a lot of money on energy, and it was clustered into a community which the mean of the energy of the money spent on energy per year, it's much lower, and that's why this saving is so high. So it's probably a really rare case, but it's just to point out that this eventually can happen in the communities.
No, and I just wanted to add that these values of the lower scores, it's for the maximum. So the street with the maximum spending would have this impact because it would be pulled down to balance out the ones that have less spending. I think this was what we were missing or mentioning, because it's the maximum, the street with the maximum spending, it would go down like by that much. Possibly.
Okay, thank you.
I have a question about your territorial thing, because you use postal codes, but in my opinion, postal codes are a bit tricky because it's some kind of a division of areas that dates back to Napoleon, I think, and it's not really it might be too big, because you have the different neighborhoods, and I'm living here in a neighborhood which has the same coastal code as the neighborhood next to it. So would it be possible to make it a little bit more refined in territorial? I blame the French, yes, probably. Yes, Napoleon, he did a lot of good things, a lot of bad things. Could it be made a bit more refined on the territorial metric, or how you call it?
Yes. To answer your question, yeah, we did we used the postal codes to select which part belongs to which community, and I think we can improve this by selecting not the postal code, but the streets, or even the number of each door. But we didn't find the data, so that's why we didn't explore that.
Okay, thank you. I still have another question, which might be a more specialist, or maybe go too much into detail. But on one of your last slides, you said you could use other factors like self-sufficiency, and I was very curious how you would do that, because self-sufficiency is very interesting, but not so easy to measure, I think, or maybe I'm wrong. Did you find any data on self-sufficiency of the Ghent households?
Yeah, basically the self-sufficiency part was more to relate to the, for example, the solar energy. So it would be very nice to evaluate each neighborhood capacity to install solar panels, and also to explore this kind of energy. And in that way, maybe be self-sufficient. Of course, this would then be divided per each community, but that was the main idea. But yeah, we did not have time, so we didn't explore that area, but it would be very interesting.
Thank you.
You're welcome.
So I have a question, and again, yeah, thanks for the presentation. So does your dashboard assume that communities already exist? By which I mean is that, it seems like what you present here is that what's the benefit for joining, but not the benefit for starting, and who starts a community? So I'm just trying to understand. Is the assumption that communities already have access to renewable sources and basically they can use the dashboard to decide whether they join, or how does this all gets activated?
I think we base this in more of a after they've been established. So this was based on we created those communities, and it would have been in a sense of after those communities would have been formed, how to keep the user motivated and how to give them a reason to join the community with something simple to visualize, not many difficult numbers. So I think this was more focused in a way to make the community and continue building up the community after first establishment. Because I think for these things, it's very important to focus on the user experience and how the people would interact with the product and how they would view the community. And without user adoption, there's no way to focus on these things. And if the users don't get what they're saying, and if they don't see possible results or possible benefits, it's difficult because it's not a magical solution. So all of the people in the community would have to work towards a better goal and to be more sustainable and adopt new practices. So this was more of a motivational thing to see results more immediately and to see if what they were doing, if it was contributing to their goals. I think it was more of that.
Can I just add something? Sorry, Madalena. We also thought about well, energy communities is such a fuzzy topic. Not a lot of people know about this. So we also, when we thought about the product, we wanted something that would be like educational in a way. So we thought that a person that pays for energy just want to see that its money is not, so it wants to see its bill getting down and down. So we wanted to integrate this user experience, as Madalena was saying, with also this educational part of energy communities. So we wanted to attract people by reducing their costs, but also try to explain them, okay, we are achieving this because you're in a community and you're working with other people. And yeah, all of that.
Right. Great questions and great answers. We have time for about one more question, if there is another one.
Yeah, Stefan made me think about something. Could you adjust the dashboard so that as a user, now you're giving these averages on street and community level? Could it be an option that you could put your real data for your particular situation into the dashboard to see what happens? Do you understand what I mean? So here I get an average, but maybe my situation is a little bit different, or it could be refined by giving in my personal data and see what I know what I'm paying for energy, for instance, and it could be motivating, I think, so to adapt it.
Yeah, that question makes a lot of sense. As of now, this is just a very simple dashboard, a very simple mock-up. So ideally, yes, that would be possible. So with more time and more available things to develop this project, that would be a very interesting end goal and a lot more useful for the users too. But yeah, as of now, no.
No, okay, but thank you.
Yeah, thanks for the question and the answer. And I think that's the moment to point out that how long did you have to develop the tech? I think 3 weeks in total. So all the teams, all that you've seen for people just watching the live stream, they've done this work in 3 weeks, and then they had about a week to gather the presentation. So this is a ton of work for not that much time. And thank you so much for the presentation, Data Warriors. Thanks all the teams for the presentations, and the jury for their great questions and their very active and intent listening, having intense and deep diving questions for each of the teams. I know that's stressful, but I think all the teams did really well. And now we are going for a break while the jury deliberates. The jury figures out how to allocate points. This will take a while, so everyone grab something to drink, everyone breathe, go outside for a second, grab a snack, and you will see a little banner on the live stream once we are starting to come back, and then we will announce the results. So yeah, good luck to all the teams. All the teams did great. This was amazing, especially seeing the different types of approaches. I think every team had a unique approach, and that's super awesome. So yeah, thanks so much to everyone, and we will be back.
Hi, everyone. My name is José Vieira, and I work at the Center for Artificial Intelligence and Analytics in Fidelidade Group. The insurance sector is full of data science challenges, such as classical supervised classification models for customer cross-sell and churn propensity, as well as deep learning and computer vision exercises, such as intelligent document processing, car damage assessment in either pictures or video, or even topic and sentiment analysis in either text messages or phone calls. All of these projects are built by our internal teams at the center. If you'd like to know a little bit more about our projects, feel free and reach out. I wish all of you a wonderful World Data League. Best of luck.
Fidelidade, so that life doesn't stop.
All right. I know that was quite the wait, especially for the participants, but also for everyone who's rooting for a team or just wants to know which solution won. And we promise we are not planning on dragging this out. We just want to have a few words with the jury and also from the organizers before we announce the winner and the order. So yeah, Leon, what did you think?
It was, I think it was a very difficult decision that the jury had to make, and it was. I thought that all the pitches were on a very good level, and it really shows that the teams have also put a lot of effort in it, technically, in both the pitch wise and preparing it. Also, I'm not sure if everyone's aware, but also all of the teams actually had that pitch training together with a coach, so they could perfect it for this day. So, and indeed, you can see very good results from that as well. So yeah, I think it was a job well done for all of them.
Yeah, definitely seconding that. Everyone did a great job. Each solution was unique. Each solution had a ton of work behind it, and each presentation was meticulously prepared. So yeah, big round of applause to all the teams. And I think that's important. I know like the teams who are winning will be happy, and maybe the other ones will be a little disappointed, but each and every one of you can be super proud of what you did throughout this whole World Data League competition. So I think with that, we let the grand jury have a few words. What did you think of this finals presentation in total?
Well, as for the city of Ghent, I would like to say a big thank you, because it was really like very impressive what you all came up with in just a few weeks. You showed very, very deep understanding of this problem, how the problem is on the territory, and I felt a lot of empathy within the proposals for how we could actually use the solution. So I was really amazed with what you came up with in such short notice, and with these data sets that we just gave to you, and the challenge we just came up with, like, okay, solve a problem that we cannot even solve ourselves for the moment. So really, really impressive. Thank you for that. And thank you very much for all your efforts and doing this for us. So thank you from the city of Ghent.
Yeah, if I may want to add to that, is that it was extremely impressive to see all of the teams to be able to grasp with a very set of complex problems, because it was not just one problem, right? So it was the issue of energy sustainability, the issue of economic inequality, notions of vulnerability, notions of urbanization, that all comes together within a particular kind of location, such as Ghent. And I thought I was really impressed with all of the teams to be able to grasp the complexity in a manner that, anyway, was really sophisticated. The second element that I was impressed with was that it was not just data crunching, but it was actually making data actionable. And I think all of the proposals, all of the teams really thought through on who needs to make decisions and how do we provide data in a fashion that is actionable. And I think the third element that was really impressive was that it was not only actionable at the level of the decision maker, but also actionable in a way that actually communities can be formed and created. And I think all of the presentations were not just solving the problem at hand, but also thinking about how do you build stronger communities within a city such as Ghent. And I think really impressive work. And yeah, I'm always, anyway, this was, as Leonid said, this was my third time. So next time, Leonid, when you ask me, I'm ready again, because I'm always learning so much from all the teams. So super interesting, and yeah, massive work that has been achieved here.
I may add a couple of words here. I agree with the other two jury members that a lot of good work done. Impressive how everybody understood the complex issue. Sometimes, you know, because I work for the United Nations, sometimes people talk to me and they say, oh, you guys are going to solve all the problems of the world, right? And I have to explain to them, no, that's not how it works. There's no way we can do that. We can be a catalyst, we can inspire people, but it is people like you who have to come up with the solution. So when I see something like this happening with people using their creativity, their data science skills to solve problems in the world, it makes me really happy. And it was great to be part of this jury and to see all these creative solutions. I can't believe that it was only 3 weeks that you guys had to come up with it. The pitches were really well done. So congratulations to everyone, and thank you for participating.
Yeah, big thanks to the jury again for jumping in and taking all of your huge expertise to ask the real important question, and sometimes the difficult questions, really grilling some of the participants, but making sure that the solutions are really fleshed out. And again, big congrats to all of the teams. So before we start announcing, as a little reminder, what probably some of the participants are also having in mind now, of course, there are prizes. It's a competition after all. The third place is going to win 1,000 euros, the second place 2,500, and the first place will go home with 5,000 euros. Of course, this is in addition to other prizes that some teams may have won in the first 2 stages. So with that, I think, Leon,
Yes. So without further ado, I think it's time to announce the teams. We will start first with the third team, and the third team is CEOs. Congratulations.
Yeah, big congrats, CEOs. You did a great job, and it's a great third place that you've won with €1,000. Yeah, round of applause. Not really that audible on Zoom. Zoom filters out applause, which is kind of mean, but yeah, great job, CEOs.
Yeah, indeed. Congratulations.
All right.
And Tamara, who was second?
Yeah, now it's up to me to say who's second. Yeah, not gonna make it long. The second team did a great job as well throughout the whole competition. We have to say, like, you will shortly know why. The second team, second place team, is the Base Bunch, who the participants know won the first two stages, and now they won second place overall. So extremely great performance throughout the whole World Data League competition.
Yes, indeed. And maybe just to add, they have in both of the stages, they have also submitted very great solutions. They were the only ones who managed to win the excellency prize. So you had to score at least a minimum number of points, which was a tough number of points. It was 150, 225. So congratulations. And yeah, it's also was really great to have you. So let's go for the first place. And I have to say this was also a bit tight. So they were both the first place and the best bunch were not that far apart each other with the number of points. And the winner of the 2023 edition of World Data League is AI Wonder Girls. Congratulations.
Yeah, big congrats, AI Wonder Girls.
Congrats.
You did an amazing job.
Let's see where they are.
Yeah, I know. I've seen some on the call. You can turn your video on, go off mic.
Thank you.
Wow, thank you.
Thank you.
This is such an amazing competition we've been in.
Exactly. I mean, I just can't
been
put into words. It's really overwhelming and amazing teamwork. We all four of us, we sort of tag team being in 4 different time zones. And most of all, thanks to World Data League for giving us this amazing opportunity and also pointing when we are not doing the right, when we are not going the right path, so to speak, and sort of giving constructive criticism. That's really important. And having been in this industry for a very long time, in the software industry and in data science for about 5 years now, it really means validation for us, for each of us. And thanks to the jury, you guys did an amazing job. Yeah.
Yeah, I mean, huge congrats. And I know this moment is overwhelming. Like, you win and then you have to come off camera in that exact moment. So that was a good summary, I think. And I think what really stood out there is, first of all, you're all in, I think everyone's in a different time zone or almost.
Yeah, we are all in different time zone. I'm in the Eastern time zone. Ernita, our team lead, she's in Indonesia. Emma is in Spain. And Divya is in India. So we are all, everybody is ahead of me, so to speak.
Yeah, I have to ask there, did you know each other before the World Data League, or how did this team form?
Yeah, we are part of, we call ourselves AI Wonder Girls, obviously. And we have done several volunteer projects with an organization called OMDENA, OMDENA. And that's how we kind of banded together. We are like, I think about 250 members now, all women, obviously. And we are all from different walks of life, all through the world. And we keep in touch and we encourage each other, whether it is education, educating ourselves, or just having some, usually we have a Friday fun fact day wherein anybody can say what they are doing for fun. So it's not just all about work, 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 work. And yeah, we encourage each other. We say that, hey, this particular course is happening. Do you want to take? Are you interested? And we also have like sessions wherein we sort of mentor each other, kind of a thing. So yeah, that's what we are.
Perfect.
Basically, we want to help women all over the world.
Perfect. And maybe now that we're finishing, maybe just one question to leave to think about into the future. What advice would you give for people who are watching and who might want to compete next year or in the next edition?
Don't be afraid. It's okay to make mistakes. It's okay to fall, and get up and dust off and get up and do your best. I mean, we never imagined that we would go past the first level. We went through that, and then we came to semifinals. We got through that, and so every level, don't expect that something amazing will happen. Just do your best. That's what would be our advice.
All right. Well, thank you so much, Wonder Girls. Congratulations to you, and congratulations to also all the teams that did a great job. I mean, I think that everyone did a really good job. And Tamara, maybe just what is the current leaderboard for the finals?
Yeah, I have the leaderboard on my screen. If you can see my screen share, is the final leaderboard with the points. As you saw, the AI Wonder Girls won with 241 points. The base bunch were very close behind with 233 total points. COs with 182 points, and then the Data Warriors and Insight Squad virtually tied, almost tied for 4th and 5th place. So yeah. But as Leon said, and as I've said before, everyone did an amazing job here. And I mean, each of these teams made it through the first 2 stages. So each of these teams completed 3 extremely complex data challenges. We didn't have any easy challenges this year. So yeah, again, huge congrats. And I think everyone can be super proud for what they did in this competition.
Yeah, and why you should be proud of it, and maybe that's where we can go to the next slide as well. One more. It's that what are actually the next steps for this is that we will take all the executive summaries that you have been writing. We will take that and summarize it even further into the insights report. So this is going to be especially useful for all the cities that provided the challenge, but also for any other cities or any other organization that might have the same challenge, on give them a bit of insights, and therefore the insights report on how they could solve those challenges, what data do they need, what other data they could collect, which techniques could be used, how could it be applied, and also what is the impact that these solutions could actually have. This is, besides being published in the insights report, it will also be published in our social impact hub, and all of this will be under Common Creatives, under the Common Creatives rights. So of course you can use it and reuse it freely, and it's going to be freely distributed. Besides this, all the code that you have produced, this is also all going to be made open source code through our GitHub page, and everything that was made during the competition will also be made open. So it's also completely free for the world to use. And another final note, we also, if you're thinking of following up with any of these solutions or would like to develop it further, or maybe you're thinking about publishing a paper on, and this goes for any of the teams from the first stage until now. We would be, of course, happy to assist you in any way we can. Sometimes it's connecting someone, it's finding the right venue for publishing. Just, yeah, whatever you have on your mind, whatever follow-up you would like to do on the work that you did, just ping us and we'll be happy to help you. And I think that's all I had to say for the next steps. So I think it's the final goodbyes now. Yeah, I think what we will do now, it's actually call some of the rest of the team on stage, of the World Data League team, just to have some really quick words from everyone, because you've been seeing me, Fabiana, Tamara, Miguel, but there's Maggie as well. But there's more people who contributed to this competition and who made it possible. I'm just going to go quickly, maybe as I'm looking at the list, I'm just going to go through for the first person, and I see Miguel. He's the first person on my list. So Miguel, he's actually head of operations. So everything had to do with all the logistics with preparing the live events, making sure also the team is working correctly, all the correct methodology. I mean, he's the guy who basically puts all the different pieces of World Data League together and make sure that everything works smoothly. Miguel, I don't know if you just want to give 1 or 2 words.
Yeah, for sure. I mean, I think it's a big overstatement, what you just said, which I greatly appreciate. But it's, I mean, it's really the merit of this team to make it work. It's already our 3rd edition, and we're getting more and more powerful, I feel. And I mean, it's a pleasure to be part of this team, and also to each and every year see more and more data scientists, some more junior, some more senior, contributing to WDL and really believing in our mission and vision of creating all of this open source knowledge and making it available for cities that don't have the human power to create the solutions. So yeah, greatly appreciate, and always very humble to see these things. Thank you.
Then the next person I see on my list, so it's basically assigned by the randomness of Zoom. Maggie, she's our community manager, and basically anything that has to do with anyone who interacts with World Data within the competition, so mentors, jury, participants, that's under her, and Alex, of course, who works with her. But she's the head of community, so that's a very also important responsibility. And without all the communication, it would also be possible, of course. So Maggie, you have a couple of words as well.
Thank you so much, Leon. You were so kind. Yeah, it was really cool to see all the teams growing these past weeks and months. I really saw a big growth, not only by seeing the solutions, but how you interact with the mentors and basically how you interact with the community. I saw some people on Discord rooting for other teams, which is really cool. So yeah, this is definitely a competition to learn, and you should be all very proud of what you did here. You are the top 5 teams. You should be yeah, very, very proud what you did. And we are really happy that you went on this journey with us, for sure. And then maybe I'll give a break to Leon, and I will pass the message to Alex, who I couldn't done any of the work without. She's an amazing community manager as well, and she helped me a lot during these past few months. So Alex, the floor is yours.
Thank you, Maggie. Hope you are hearing me well. Yeah, okay, so yeah, I just not only congrats to the winners, but also to top 5 teams and any team that submitted any challenge. I love to see how engaged all of you are and how focused you were on the challenges, and hope to see you in the community, in the networking areas, and in the next edition of WDL. Thank you.
Perfect. Thank you so much. And then as well as if you remember the beginning of the session, I talked about all the partners that we have, especially the corporate partners, and that help us also not only support us through mentors and juries, but also financially. And there's one person responsible for gathering all those partners. That's Rui Mendes, without whose work also this would of course not be possible. So Rui, the floor is also yours.
Thank you, Leon. Hello, everybody. So I want to congratulate all the teams, especially all the winners of this edition. They were amazing presentations, a great job. I hope that all participants learned and enjoyed this experience. I'm sure they do. And of course, I want to personally thank the sponsors who, as Leon mentioned, played a fundamental role in making the competition possible. So many thanks to all the companies for their trust and support. And of course, thanks also to all the mentors, judges, and of course, the entire staff team. This is a great team. So nothing more to say. Have a great rest of the day, and now time to celebrate.
Woohoo. And as well, there's some people who are missing here, but I think they're very important to mention. There is Fabiana, who is head of communication. She is responsible for getting the word out on World Data League. So most of you are here because of the work that she did in communicating that the next edition is happening, making sure our social networks are up to date, making sure that the newsletters are sent out to all of our partners. That's also her work. So she does a great job. Unfortunately, she could not be here as she had to leave for her train. And then two more roles that are also very important. Celso, who designed all the materials, and he designed our website. He created the image of World Data League, and he's a designer. And finally, João Martins, who developed the submission platform. So when it did not work, you also know whom to blame. But in general, I think he did a really great job and works perfectly. And finally, Tamara, I mean, I think I can also give a word about Tamara. She was, even though her role on the website says data scientist, I think she could be also called talent managers, because this year she really took on the role of communicating with all the topic entities that provided the challenges. She went through all the data. She made sure the data is correct, and she also prepared the jury brief for the technical jury so that they do not have to go through the data themselves, and they know what the participants have access to. So I don't know if Tamara, you also want to add something.
Yeah, I think just reiterating, everyone did such an amazing job, especially seeing all of the challenges from the first moment where we discussed with the city, from the first email usually, where they said, hey, we have this idea. Sometimes we didn't know yet what is the data, and the idea wasn't fleshed out yet, or we still had to figure out, is it even feasible? And the first challenge we really got together was, I think, in December or end of November, December, when we started. So this was a long time in the making. And then seeing all of the participants, what they did with that is just amazing. Like, I just scratched at the surface of the data just to make sure it's all there and have a bit of an EDA, but then the participants went so much deeper and just amazed me with their ideas, with their models, and also with their presentation skills, especially today. But it's a live presentation. Everyone did such an amazing job, and it's humbling and it's motivating every year to see people come together to work for the social good and for the betterment of humanity in the end.
All right, and I think with those words, we're ready to close World Data League. So thank you again to everyone. Thank you again to all the participants for creating amazing results. Thank you for the mentors who helped the participants. Thank you to the technical jury who kept the participants on their toes and evaluated all the code and looked through all the notebooks. Thank you to the grand jury who asked a very important question, helped us also to evaluate the final winner of World Data League, and to all the sponsors and also all the partners. Of course, without mentioning, you've been watching this live stream, there's Ricardo also in the back office, who also helped us a lot. Huge team, a lot of great outcomes, and we hope to see you next year. Thank you so much, and goodbye.
Hi, everyone. My name is José Vieira, and I work at the Center for Artificial Intelligence and Analytics in Fidelidade Group. The insurance sector is full of data science challenges, such as classical supervised classification models for customer cross-sell and churn propensity, as well as deep learning and computer vision exercises, such as intelligent document processing, car damage assessment in either pictures or video, or even topic and sentiment analysis in either text messages or phone calls. All of these projects are built by our internal teams at the center. If you'd like to know a little bit more about our projects, feel free and reach out. I wish all of you a wonderful World Data League. Best of luck.
Fidelidade, so that life doesn't stop.